subscribe and press this bell icon to never miss another lecture video. Write it down in your note in your language. Okay, this is our first note point. Okay, we'll move to the second note point by understanding this example. Look here carefully. I have combined the last two questions, that is f1t plus f2t. I made it like f1t and f2t. Okay, now we know the property, linearity property, right? Linearity property. So apply the linearity property. It says a1 f1t plus a2 f2t will be nothing but a1 f1 omega plus f2 a2 f2 omega, which will be nothing but given as, what? 1 by a plus j omega plus 1 by a minus j omega. So which is nothing but is coming out to be 2a by a square plus omega square. Please look here carefully. Observation, very important observation here. Linearity property use करके we find out the answer here very quickly. But the note point that we got here, a real signal and even, this is a symmetric signal. Come out to your overall analysis. ऊपर से देखो. Look from the above. It looks like a symmetric signal. So always remember note point. Second note point is, if your signal is real signal and even, yes or no, ये real भी है और even भी है, then look here carefully, then Fourier transform is real. Fourier transform is real. Look here, it will never ever going to have any complex or imaginary quantity. This is the part of a property that I have discussed with you in the property table. Okay, you can look here, we got a real value here, if as it is real and even. But look here carefully, the second example, this is a real and odd signal, Put that linearity property and find out the Fourier transform. So Fourier transform will be 1 by a plus j omega minus 1 by a minus j omega, which will be nothing but minus 2 j omega by a square plus omega square. This will be the value. So here what is the observation? If your question is real and odd signal, Fourier transform will be imaginary. So you can write down third observation. If it is real, if your signal is a real signal and odd. Sir, ये odd कैसा हुआ? Because it is antisymmetric about y-axis. No, that is why I called it as odd signal. Then your Fourier transform is, look here, Fourier transform is imaginary. Okay. Now moving on. Listen to this carefully. This is a very important point here I'm going to share with you. Look here carefully. We got an example here, which is the combination of a ramp function and a decaying exponential. A ramp and a decaying exponential. Now what will be the Fourier transform of this? So you can solve it like t into e to the power minus at ut into e to the power minus j omega t dt. This is the way that we should do minus infinity to infinity Fourier transform. But here you can see how many functions are there. Like here it is one function and ये और एक function है. So by applying UV method you can solve this. Okay, that's great, but you can't solve it in GATE exam, right? Now you need to use the property here. So what kind of property is very much useful? Sir, there is a property which is called as, if f of t Fourier transform is f of omega, then t into f of t, the Fourier transform will be j into f dash omega. What is f dash omega? That is the derivative of this dy d omega of f of omega. Absolutely correct. So it is in this format, I think. Yes. So we are going to apply this frequency differentiation property. That is what it is. Now if you apply the frequency differentiation property, then f dash omega will given as, I think it will be minus 1 by j by a plus j omega whole square. Okay, now this will be your f dash omega. Now what will be the answer for t into e to the power minus at ut? What will be the answer? इसका Fourier transform into, there will be a minus j here, I'm sorry, j here, no, j into f dash omega. F dash omega is given like this, minus j by a plus j omega whole square, which will be nothing but 1 by a plus j omega whole square, which is nothing but its graph looks like something this. Clear with this concept? Okay, here what are the things that we have studied? We have studied about what are the things that we are going to cover in our entire syllabus, and we have started real exponential signal. In the first place, we have started with a one-sided, single-sided real exponential, and we found out its value. We found out its value and we factorized it, and we found a very important observation. It is observation 1. Please write it down in your words. Then we have analyzed its magnitude spectrum and its frequency, phase spectrum. So that means the entire frequency spectrum analysis we did here. So this is your frequency spectrum analysis, right? Frequency spectrum analysis. So this is your frequency spectrum analysis, magnitude spectrum analysis, and phase spectrum analysis we did here. Then we moved to solve the same kind of question but in another side. Okay, then we combined both, and we took out the node point for this thing, and also then we did the solution of the same question with double-sided exponential signal, and we found out the node point of this thing. So there are 3 very important node points that we have covered here. Please go through those node points, and at the end we have solved a ramp into exponentially decaying signal, the Fourier transform of this complex, very complex looking signal. Complex looking means मैं वो वाला imaginary वाला complex नहीं बोल रहा हूँ. It looks very complex, but we solve this question by applying a very simple method, that is frequency differentiation method. With this, we are done with today's lecture. Thank you so much for your patience. If you have any question, query, feedback or suggestion for this video or this channel, feel free to write it down below in the comment box. And if you want more and more videos like this, give us a thumbs up and do subscribe to our channel GATE ESE Lecture. See you in the next lecture, where we're going to solve or analyze a couple of Fourier transform of couple of standard signals like delta signal, step signal, like that kind of signals. We'll see you in that lecture. Till then, bye.